So for a long while, I've actually really disliked fragments and the way that they operate independently with everything else, and they're just really difficult to use. And I've had a really poor experience with them. But then using them with the navigation component has been quite refreshing, and it's been an interesting journey. So I wanted to share that with you today. So navigation is hard. And now that might not be a great start to a topic, but it's a very accurate misnomer. And it's a topic of confusion for a lot of developers. When you're starting with the platform and coming into with a new set of eyes, how do I go from one screen to the next? And that's really important because navigation is such a fundamental part of your application. It's how you get from one screen to the next, how you actually separate content and provide a nice experience for your users. But if it's just moving from one activity to the next, why is it so complicated? What makes navigation so confusing? So I guess it starts with the Android framework components. So Android framework components are probably what you're already familiar with. These are activities, content providers, services, broadcast receivers, and fragments. Now the important things about these are that they're controlled by the Android subsystem and not really instantiate themselves. So you have to allow the system to manage this navigation for you, and then this involves lots of different serialization and otherwise. But let's start simple. So let's take a basic activity. In its simplest form, you have an intent to navigate from one activity to the next. So in this example, you've got the intent being created, and this activity knows about the next activity, and it knows what parameters need to be passed onto that next activity. So you've already got a bit of confusion here, or a bit of kind of too much knowledge sharing going on here. This activity knows more than it needs to. Now, of course, you do need to have this contract somewhere that to start this activity, you need to provide this information, but it should be the responsibility of the calling activity to know this and serialize it. So when you have this individual behavior required on every single activity navigating from one next to the next, then it quickly becomes unscalable and it's difficult to manage. So in large applications, it just kind of goes completely out of control. So this sort of begs the question, how are we supposed to do this? If Android provides us with these different frameworks, what's our recommended use case? What should we be doing? And it's important to remember that this is, Google doesn't really care. So back when Google Plus was still a thing, in 2016, Diane Hackborn had said, once you've gotten to the entry point of your application, Android doesn't really care how you do your architecture. And this was to kind of promote flexibility and to allow you to have the creativity on whatever architecture mattered to you and was important for your project. So this was kind of controversial because people still wanted a bit of guidance and a bit of help, a bit of kind of pushing in the right direction while still having that flexibility. So this is what makes Android so powerful, is that we have this flexibility that we can change things around a little bit. But if you're new to the game, where do I start? So then this is sort of complicated by the fact that they introduced fragments in Honeycomb, this is the calculation 14, sort of break up screens into different concerns. So it sort of builds more richer interactive user flows that you can separate for multi-screen devices. So think about tablets or large TVs or even still using devices and phones or phablets. But this was important as a stepping stone for Google and Android, because this was like starting to think about oriented design and sort of introduce this thinking about design-oriented thinking. So the example of this is the master detail interface. You're probably familiar with Gmail or with contacts, where you have like the list on the left and the detail on the right. And then if you were then to translate this onto a handheld device, then you'd have a different behavior. So instead of master detail, you have actually master detail with navigation. Now this was the main selling point for fragments, and this is what we were supposed to use it for. And the idea was that we could have separated individual UI components, and these will all work properly on small screen devices, and everything was consistent and happy, which was not great. But how would you do this? I mean, we saw the implementation of a navigation from one activity to the next in the previous slide. So if we're doing this with a fragment, how would that look like? Now this is the sample from the Android documentation. It's not Kotlin and it's not pretty. But you can sort of see what's going on. You're creating a fragment, you're adding it to the fragment transaction from the support fragment manager, as so. You're also setting the extras on this fragment. So in the same way that you're serializing the bundle on the fragment, on the activity, you're doing this on the fragment as well. A bit more complex than starting an activity, and you've got a bit more caveats in there as well. For example, you've got this save state problem. Now, if you've got retained fragments, or if you've got a fragment being recreated afterwards, then you don't want to add another fragment, because then you have two fragments, then you have the double fragment state, and then you have communication going on that you don't want to have. So then you have to check this save instance state. And I mean, when I first came to Android, I had no idea that save state being null meant that it'd been recreated. I was only just getting familiar with what orientation changes were. So what would tell you as a new developer that save instance state is null, that means I don't create a new fragment. That's not inherently obvious. And then that's furthermore complicated by the fact that, well, the activity lifecycle is not the same as the fragment lifecycle. It's extremely different. And there are lots of different gotchas and lots of different kind of caveats that can really trip you up as a new developer. I'm going to mention like on attach as an example, which you're probably all familiar with. And then add another complexity to this. The activity lifecycle is not equal to the fragment lifecycle, not equal to the view lifecycle. This is when a fragment is not yet attached, but the view is still there, and it's a whole different thing. I'm not going to go into it, it gives me a headache. There's a nice little graph from Jose, where it shows the differences in the behavior of the fragments, based upon whether they're retained or non-retained in the orientation change and the actual sequence of lifecycle events as they're occurring. And you can see how it relates to how it might relate to the activity, where you've got some of the undetached and undestroyed things being called in some circumstances and not in others. I'll share the links at the end if you don't get a chance to catch it now. To add to this, explicitly invoking add to backstack on transactions can really mess up your backstack if you're not using it properly. So you can end up with the invalid stack, unexpected behavior, configuration changes, and it's just like not so great. But also a side note, does anybody recognize that? Well done. I was hoping somebody recognized that. Great. Also, so you've got also the support fragment manager and the child fragment manager. Which one should you use? This is actually pertinent when you're working with the paging with paging tabs. If you have fragments inside that, if you have dialog fragments, then fragments can have other fragments, and fragments can have retained fragments, and the fragments can have paging fragment. Lost myself there. But it gets quite complicated. And you can quite easily leak context if you're not doing it properly. Other complications are communication between fragments. So I've seen in the past a lot of people trying to use event bus to pass communication between fragments over activities, or communicating via the application. And it's generally been a bit difficult to manage because you don't know what state that other fragment is going to be in. So you have to kind of enqueue something to be picked up next time it's ready. And then of course you have the issue with bundles, same as you would with activities, but you have to let the system instantiate these fragments, so they have to make sure that these parameters can be serialized and deserialized by the system when it needs to destroy or recreate your fragment as is necessary. But the point being is that you can't actually use fragment constructors. So dependency injection sort of goes out the window there. We have to use this deferred dependency injection via inject annotations and having late init properties or nullable properties or non-null properties or anything that's necessary to get the job done, but it's still not as clean as constructors. That is until, of course, we get access to the fragment Android X library. Now, this has only been recently made stable, but I recommend you go and checking it out. It allows you to actually specify a fragment factory which you can register on the support fragment manager, meaning that the system will then use that fragment factory to instantiate your fragment, much in the way that you would do so with view models. It means you can inject dependencies into this fragment, and then you can actually safely use fragment constructors. It's quite nice. So with all these kind of complications and difficulties and caveats and gotchas, you might justifiably ask the question, well, why should I use fragments? This sounds like a horrible thing to use. And these are pretty compelling arguments, just stick to activities. And when I started out as well, I would always prefer to use activities instead of fragments. And there's a good reason for doing so, because you get to avoid all of this stuff. And then this actually introduced a lot of other architectural types, and a lot of other types as well. We have things like Mortar and Flow, where people would be using custom views and custom implementations just to avoid this fragment setup, but still have individual kind of modularized components that didn't need to be an entire activity. So that does then beg the question, well, maybe fragments are fit for purpose, but they're just an absolute headache to use. So there are some good reasons for fragments. let's take a look at those. So one of the things about fragments that became really powerful in more recent years are basically down to activity capabilities. Now, the activity is still part of the Android framework API, so this means that you have to update your minimum SDK or your target SDK as relevant to actually start using these features. And you can only use these features once these features are actually available in your APK, in your actual framework code. However, that's not the case for fragments, because fragments are actually part of the Android X library or the support library, so you can actually start using them straight away. And they don't need to be backported because they're actually a library. Things like shared element transitions. This is an API 21 plus. Now, there's a really nice article, I think, from Ian, I can't remember off the top of my head, but I'll share it later, where shared element transitions are only available on API 21 and above. So in the Compact library or the Android X library, this is sort of survived with a Compact ship, which will then try and gracefully perform the same operation on APIs where it's not available. But on APIs where it goes a bit further back, it just simply doesn't do anything, and it doesn't have the same behavior. So you have sort of a Frankenstein app where you don't exactly know how this animation is going to behave, because it's going to behave differently on different versions of the application. So Compact ships aren't really enough to get the job done, because we don't know how it's going to react. And it can sometimes actually behave in unexpected ways and provide kind of inconsistent user experience, and it doesn't guarantee that consistent user experience that you might be testing locally. As mentioned, the fragment is available in the Android X library. It used to be on the framework, but then that's been deprecated in favor of that. You should all be using the Android X fragment if you're not already. And this is native as of API version 28. And you can use this up to, I have no idea which version of API you should use, but you can already use this straight away. But one of the nicer things about fragments as well is that it introduces this concept of scoping. Now, this is really pertinent if you've got dependency management and you've perhaps got a couple of screens where you want to share some dependencies across these screens, like repositories or kind of caches of data from user entry. And you don't want to serialize all this content into a bundle passed between activities, but neither do you want to pass this into a repository that's scoped into your entire application, because you're using it in a few activities. So how would you effectively do that? There's no Android framework component that sits between an activity and an application, so there's nothing for us to use there. So if we move it down a scale, and then we actually treat fragments as screens, then that allows us to use an activity as a higher scope than that. So we can sort of start off with like 2 activities, for example. There's no real physical connection between the 2, but then if we change it to, sorry, this is the application, I'm ahead of myself. So the application would be your scope higher than that. There's nothing really in between. But then if you introduce fragments into this activity, then you can sort of share dependencies and resources in this activity, which can then transcend through a few different screens with fragments. And then you have things like shared view models, which you can share between them, which you can reliably share data with without getting destroyed on configuration change, which means you actually got a nice structure to start using with native framework components. So with all these nice things about fragments that we can use, but all these negative, horrible things, how can we have our cake and eat it too? I actually lament using that phrase now, being a British person, sorry. But we want to be able to benefit from all these nice things about fragments without suffering the difficulties. So, introducing Jetpack. Last year, Google introduced us to Android Jetpack with a lot of tools and variety of tools dedicated to helping us bootstrap Android development. It's sort of opinionated and clean implementations of common use case problems, with kind of suggestions for compartmentalization and suggestions for kind of how to solve these problems in an ideal world scenario. It's important to remember as well that these aren't like gospel. You shouldn't always demand to use these. If you have a different implementation that works better for you, then by all means stick with that. But the point of Jetpack is to provide a suggestion, to kind of push you in the right direction and provide a little bit of information for new developers who might not be used to these problems. So that first started off with renaming of the support library, repackaging this, and then separating the individual version numbers into individual libraries so that we weren't all having the same version, I think 28 of the support library, and then the same artifact that was necessary. And it's split up into about 4 different fundamental components. So the foundation components, this is sort of picked up where the support library left off, including KTX helpers, multidexing, security. You have the architecture components, things like live data, view model, navigation, paging, and the root persistence library. You have behavior components, so this is things like media playback, notification, permissions, and slices. And finally, UI components. So these are things like fragment transitions and animations, and our most favorite thing, emojis. So going back to the navigation library. So navigation library is obviously what I've covered in this talk. Navigation library is a set of libraries, a plugin, and tooling that allows us to unify and simplify Android navigation, solving all the problems we had from fragments, allowing us to actually benefit from all the benefits of those fragments and scoped and compartmentalized implementations. It handles a lot of the common parts of navigation problems and patterns, and handles patterns like draws and bottom navigation quite easily. So you have the fragment transactions, which are handled for you. You have up and back actions, which are handled. Standardized transition resources. Deep link implementations, which is awesome, but I'll go into that in a minute. Easy navigation patterns. These are straight out of the box, useful for you. And most amazingly, type-safe arguments through the safe args button. One of the important things about the navigation library is that it utilizes or kind of demonstrates the principles of navigation in a consistent fashion. And the principles of navigation are a set of consistent, intuitive UX design patterns which demonstrate affordance and user expectation, and making sure that you have a really clean and consistent user experience. These are designed to implement principles by default. So you've got the fixed start destination. This is where every app has a fixed start and will then have the same navigation through the application lifecycle, and will start and then have an end and then can go back. And you can always go from the first to the last screen, from the last to the first screen by pressing the back button. You have your state as a stack, and this is that your navigation state can be represented as a stack of destinations, one on top of each other, and the history can be reversed or replayed as necessary, per user instruction or by your own behavior as necessary. The up and back task are identical within your app's task, meaning so if you press up or press back or up from the taskbar, these will do the same thing. But the back button, the up button, will never actually leave your application. So you can always imagine this. You might think, like, why would my up button not exit my application? But this is because you shouldn't show your up button if you're at the top level of your application. So think about the Play Store or any other library or any other application that has a navigation drawer. You have the hamburger menu, or you just don't have an icon there. You'll only ever see the up button if you're no longer on the top tier of navigation. You're a bit further down, and this means that you can go back up. And back button, it should behave exactly the same way as the back button on your browser does. And additionally, the deep link should simulate manual navigation. This means if you provide your users with a deep link, whether from a website, from a notification, from a marketing scheme, or from an email, it should have the same route to that screen as it would if the user had actually manually navigated there. So that if the user presses a deep link, they go to a screen in your application, and then they press the back button a few times, they should see the same stack of screens as if they'd done that themselves. Cool. So the primary ideal of navigation is to make the APIs as accessible as possible. And it's not limited to private APIs, and this means that you can actually implement your own behavior if you wanted to. So you can extend and mutate this behavior if you need to, because everyone's app behaves a little bit differently, and you might need some special behavior. The nicest thing about this is that, like I said, it does not use any private APIs. So if you want to implement your own navigation library, there's nothing stopping you from doing so. It might not make sense, but you can still do it. So it's built from 3 components. So the tooling, this is the navigation graph provided in Android Studio. This is available from Android Studio 3.3, and it introduces the navigation editor as tooling. So the graphical editor builds your application navigation graph. It's composed of 3 components furthermore. The first is the destinations to the left, which are highlighted in the square here, showing the host and the graph hierarchy. Destination could be an activity, fragment, dialog, or custom view, or anything you want to define it as, but you can see clearly your list of destinations in your host fragment. Next, we've got a kind of visual editor showing the behavior, or the kind of relationships between each different screen, how one screen navigates to the other, and what's going on here. And it's a really nice visual indication of what is going on. So you can, at a glance, see what's going on in your application and see how things should be structured. I think I actually had a new member of our team join us recently, and I showed her the navigation graph, and it was a really nice kind of training exercise to understand how things move around in your application. It's a really nice overview. And these, of course, these arrows, each one of these actions can be invocated programmatically, and it shows how you kind of move around in your application. Thirdly, you have the attributes for each destination. Each one of these attributes will have properties here displayed. And these are the things that will be like arguments, global actions, or deep links. And this is where you have a visual representation of the arguments necessary to provide for your application, of your activity, sorry. You might have remembered from one of the earlier slides I showed you where the activity was manually creating an intent and manually serializing this data on the bundle. This is where you'll specify the argument and say what type it is, whether it's nullable, whether it has a default value, and how to handle that, and how that behaves with your deep links. But if visual editing is not for you, you can always use XML. Not a big fan of XML, but I do actually prefer hand coding these things because it gives you a real appreciation for what's going on behind the scenes. And one of the important things when the team were developing this is that the code generated by the visual editor was readable to users and could actually be interpreted quite easily. So we're looking at that, it's kind of straightforward what the arguments are, it's not bloated, it's not too cumbersome, and it's declarative in its declaration. So I mentioned that you can have multiple different destination types. The ones used here are fragments, but you can have an activity as destination type, obviously the fragment, dialogue as of 2.1 and above, and you can also have custom types. Now if you've got a custom type, if you're using something like custom views or the Mortar flow or anything that is specific to your application that doesn't quite fit the mold for these templates, you can actually define your own destination type custom behavior. There's a guide there to do so. So first off, you sort of start with extending navigator with your type. And this will sort of say what type that is I need to navigate to, and then you'll provide the destination implementation. And this is how instructing the navigation library what the destination look like, and how to kind of get there. So you have the configuring of arguments after the inflation. So in the circumstance of fragments, you might want to inflate it and then provide the arguments, or even maybe with activities sometimes. And then you have the nav controller, which will need to have to register this destination type navigator. Quite similar to how you might handle with fragment factories or model factories. It's a similar kind of process. You also have to handle backstack navigation here as well. So if, for example, because prior to 2.1, dialogues weren't actually supported, so to actually get this supported, we had to build our own navigator type. So this is what we handled, but then it was a bit complicated when you had to have dialogues which might display on other dialogues, and how should the back behavior happen then, because dialogues aren't technically in the backstack, so it was a bit kind of complicated there. So you have to really kind of handle it carefully. Safest bet is to just use the pre-built templates that are available for you. Now, you might have noticed as well, this is XML, so of course it does involve resource inflation. All XML requires resource inflation, which means it's subject to the same lint rules as your layouts are. So there's this compile time validation of resources, making sure you have the right ID names and everything is there correctly. And though the downside of this is that even if you have the right names and everything looks right and it compiles, if it's not the right name or the graph is declared incorrectly or the ID is incorrect, you will get a runtime error, unfortunately. There's not really much a way of avoiding this unless you're actually building everything programmatically. But this doesn't really have any inflation cost. This is already part of your inflation, so don't have to worry about any performance impact here. So then we've got as part of the libraries part, we've got the nav host fragment. Now the nav host fragment is sort of where everything is controlled from. This is the sort of top tier element. It's just a fragment with a default nav host fragment provider. And this is telling the navigation library, this is going to be the host for all of my behaviors and all my components and all my destinations and all my other navigation. It's compatible only with fragments as navigation, but it means that the lifecycle, the configuration changes, the animations, all of these are handled automatically for you. And it's quite cheap, and it's basic entry points to use in the graph. So here we've got the default nav host defined as true, which means that this is the only one on the screen, and the nav graph is the one that the resource is provided in your resource folder. Now on your nav host fragments, you'll have a nav controller. And this is sort of where you dictate where you're going from each one of your places. So you say from this fragment, navigate to this fragment, as you saw in the visual editor earlier, with the relationships between one screen and the other, how to actually get from one. You're using the nav controller to do this. And it manages navigation with the navigation host, and it can be retrieved from a fragment, activity, or a view. If you are retrieving it from an activity, you need to pass the ID of the actual fragment container. So yeah, the fragment find nav controller, on the view file nav controller, and on the activity with the view ID. So with the actions, you can also actually specify them as click listeners. So you can actually use the extension to provide you a click listener that you can just set directly onto a view. So you're just going to set in the click listener, and it's a nice kind of create, navigate on click listener, which you provide the destination target. Whether you provide any bundle at all is up to you. So this is quite nice and quite useful. But one of the nicest things I found about the navigation library is how it handles deep links. Now, deep links are incredibly powerful for you as an application developer, and as well for marketing or kind of promotion or engagement of your application. But setup can be a little bit tricky and a little bit convoluted at times. So, who's worked with deep links before? Cool. Who's worked with intent filters before? Who recognizes this? Yeah. No. Yeah, that was a lot of information to take, so I thought I'd break it up with a few memes. You're welcome. So deep linking can be really easily achieved by using the navigation library.
You lost the video?
No, my memes. There we go. Yeah, failures are always resolved by unplugging something and plugging it back in. What we call IT support. So yeah, deep links allow you to so navigation library allows you to build these deep links really easily by specifying it in your navigation graph. So in your navigation graph, you'll specify this as in your manifest. You'll specify your nav graph here. And this is simply just one line statement that you will put instead of your intent filters. And then in your navigation graph, you have your deep link defined here. You want to have auto verify as true to make sure that you enable link handling verification. But you just have your URL with the parameters in the URL. Now these parameters will need to match the arguments that you've got in your navigation graph as well to make sure that these are provided when your activity is started. And that's all you have to do. You can, of course, change the URL to fit your requirements. Say, perhaps you need user ID via query parameters or additional query parameters, or you can change it however you need, and it will work out of the box. You don't have to worry about its intent filters or any of this setup. Awesome. Though there is one little caveat, you need to remember this. This is because the navigation component is still under active development. There are still some bugs being found here and there. And that is optional arguments. So perhaps you have a URL query where some queries are like optional or they have default values, or maybe you have some UTM tracking information that you don't know is going to be there or not. Currently, the parameters provided need to be present, all of them, and it needs to be ordered as well. That is until 2.2 Alpha 2, which means that parameters provided with the defaults in your navigation graph will be replaced with default in the deep link. But if your regex, it's using regex under the hood actually, this is why it's quite difficult to manage. But if you find that it's not matching it, what it'll do, it'll still start your activity, but you just won't have the right parameters. So this is an important thing to kind of check for. If you're finding that your activity is being started, but you're not sure why the parameters aren't there, it's probably because they don't match the URL signature. So this is how you define implicit links. And implicit links are sort of how you are defined in your manifest, and then you can navigate there from elsewhere. You access them by URL navigation, and they work best in app-link environments where you have perhaps a website that represents the same screen as you have in your application. But you also have explicit links. And this is sort of pending intents, which can be assigned to navigation behaviors. So things like notifications, widgets, or kind of screen widgets, or view click listeners, anything that can take a pending intent, you can define an explicit link for. And you do so with this. So you set your graph, you set your destination, you set your arguments, and then you create a pending intent. Then you assign the pending intent to your navigation, to your notification, to your widget, to whatever is necessary, like so. You can also do this from the nav controller that you can be retrieved from the nav host. I think you can start activities as well from this if you want to explicitly kind of immediately call it off. So that's covering deep links. So you might have different navigational styles. Not everyone has the same template that we all kind of use, and not everyone's following the same material spec. We might have different kind of different designs. So perhaps you've got the toolbar navigation, which is quite common, with a secondary toolbar for its contextual variant. You might have the bottom navigation bar, which we all love from the iOS world, and its contextual variant. And then we've got the good old favorite, the navigation drawer. Now, no matter what sort of navigation paradigm you're using, these are still compatible with navigation component. You just have to set up with nav controller in your activity. So, in activity, it might look like this when you're actually calling on create. You'll make sure to set up with nav controller, set your toolbar up with nav controller. And then you can provide different configurations specifying your different behaviors, whether you're using navigation drawer or bottom navigation or toolbar or any other sort of navigation component. And these have a content flavor as well with an extension function. So you can provide these different things, and these are quite useful to use. Most of the time you won't need to use them, but it's really useful should you need to. So you just provide an app bar configuration which has top-level destinations. This is the top-level destination is defined as whether it should show the up button or not. So if the current activity is a list of top-level destinations, it won't show the up bar. Otherwise, it will. If you define it incorrectly at where it shows the up button and there's nothing to do, then nothing's going to happen. But maybe you want that to happen. Maybe you want to have like custom behavior or something like this. If you're using the draw layouts, obviously this is catering for this. You can define a fallback up listener. So if you've defined an up button to show for the screen, but there's not actually an up behavior to happen, you can then specify that. Perhaps you want to have a custom icon there to do something a bit differently. And this is how you do so with a destination change listener. This destination change listener will be called every time the navigation has been called to navigate from one screen to the next. Not a closed API. You can just modify this functionality. You can check out the code and see how it handles it under the hood as well, and it's very similar. You can just sort of mutate or copy or paste or whatever you need to do. So that's the destination change listener. So finally, probably the most exciting part of the navigation component, at least for me, was the bundles. Now, you're probably familiar, as mentioned a few times already, how you might have to serialize and deserialize data coming to and from an activity or fragment, because, of course, Android has to handle this navigation. And bundling has always been a kind of source of pain for us. So how do we reliably deserialize and serialize? How do we store these keys? And do we have them on the caller site, or do we have them on the destination? Do we have like a delegate to actually implement this? Now, I feel I should mention the library from Eugenio Melotti. This is one of the first libraries I started using when I started using Kotlin, and it was a really nice implementation. It uses Kotlin delegates to define properties on the companion object of your activity, meaning you can then specify and add arguments on the companion as and when is needed. And it looks a little bit like this. So you've got your intent extra defined as an actual extra property on your intent. And then your actual kind of starting method, you would then just say, provide that method and it will assign it as so. So you don't have to worry about naming or sharing this name behavior, and you have a single definition, a single source of truth for this declaration. Now this was nice, but nice is just nice. We're Kotlin developers, we can do better. So this is introducing the final part of this trifecta is the plugin, the SafeArgs plugin. Now this is a fantastic introduction because it generates type-safe code for serialization and deserialization of your arguments necessary for your activities. So you probably saw from the You probably saw from the destinations earlier that there are arguments specified. And now the safe args plugin will take these, and it will, from these actions and from these arguments, it will then generate a type-safe implementation for you to actually pass for this. And then when you call navigation with a destination, it will require you to actually pass in this args object, not a bundle, an actual fully qualified, fully propagated args class. So imagine something like this with the main view to balance destination, just a simple navigation, and you're setting text in the fragments as a result of that arg.balance amount. Now, on the args there, you've got the actual property that you've serialized as an actual property. This is generated as a Kotlin class. That's the most amazing thing about this. It's not just generated code, it's Kotlin generated code. So null safe, default parameters, all the bells and whistles, all the dog's bollocks. This is what it looks like. It's not pretty. But generated code never is. I realize this is actually from my source code. Yeah, so you got the balance, you got the safe handling of null properties there, and it actually has the constructor there for the value, and you can deserialize it from a bundle as necessary. This happens as well for the directions. So if you say a direction navigate from this activity to the next, you have to pass this information through. And it means you have a single source of truth. And the single source of truth is defined in your navigation resource, and you don't have to worry about it being defined anywhere in your activities, anywhere in your fragments, or anywhere in your navigation components. You just define it once in your resource, and then you have to pass it. If you change navigation, if you change a parameter, it breaks. It doesn't compile. You don't get runtime crashes, you don't have any of this crap. You just have compile time safety. And the best thing is this can already start you work with activities. So you don't have to already be using fragments. If you're not using the navigation component already, you can just already use this with activities and define your activities as a destination with the parameters. So for example, you might have a bundle to bundle like this. And you can just split it as it is. It's sort of speaks for itself. So getting started with SafeArgs, you simply just use it as a plugin, define it as a class path, and apply the plugin here. And then once that's done, all your all your navigation resources will generate this class appropriately. But if you're migrating, how should you migrate to the parting library? Well, carefully, as you should with any migration. But it might be difficult if you're using activities heavily, because you might have a lot of logic encapsulated in your activities. But you can still use SafeArgs for your activity implementations. And you can start kind of moving these things away little by little, and you can then sort of see the benefits of migration and decide on how deep you want to go into it. So consider left an activity display list, and on the right an activity to view details. I think I've got a few minutes left. So ideally you want to start moving the screen behavior away from the activities. You should already be doing this. You shouldn't really be doing much in your activities already. So you want to use view models already to make sure that you're abstracting this away. And then you can create one new activity for your fragments. This is sort of a blank activity with a host fragment. Just can be a frame layout, and then it just can be a later host for a navigation graph. So you start by moving existing activity logic to a fragment, updating layouts for fragments to update your data binding. So your data binding layouts expects it's a fragment, and you extend a fragment instead of an activity. You change your onCreate to onCreate view because it's now a fragment, so then you have implementation logic there. You need to inflate your layout as appropriate. You move your view created behavior to onView created. This is when stuff has happened already and you want to configure the layout afterwards. You have to make sure that you change your lifecycle owner to be the view lifecycle owner, because as I mentioned earlier, the view lifecycle is not equal to the fragment lifecycle, nor is it equal to the activity lifecycle. Mouthful. Make sure that's updated, and then you initialize the fragment in the host activity that you created, this blank activity that can just then instantiate a fragment. And you do so like you would any fragment, really. You just add it to the fragment manager if the save instance state is there. So this is obviously not the best implementation, because you still have to be worried about whether you're having the save state instance that has been recreated. But this is sort of like in our migration phase. We're moving over. So if we want to add parameters onto this, if we want to add some cheese to our cheese list, this is how we would do it. Same intent extras as we would normally. Then you can create your navigation graph using these fragments. So These individual destinations exist as individual elements in your navigation graph with fragments. You have your list and your details, each with a label and a layout, so that you can see in the IDE which layout they're referring to and how they interact with each other. Next, you want to create a navigation host. This will be in the host activity that you've created earlier. This indicates the default nav host, so it's the only one on the screen, and the main graph as a navigation graph that we're going to be using. And then we don't need that behavior in the activity anymore. This is actually handled by navigation components. So this ugly add fragment with the support fragment manager, checking if it's saved instance state, no longer necessary. Just create your activity. You don't actually need anything more than that. I've got a few activities in our project which are literally just that, like that, and it's beautiful. So then you specify your directions in your navigation graph, in your resources there. So you've got your action going to the other screen with your argument necessary on the next screen. This makes sure that these dependencies generated class for your arguments knows that if you're navigating from this screen to the next, you need this argument, and it won't let you do so without having this argument present. So then in your fragment, you might have a binding for your list adapter, and then you've got your directions, which you have on your nav controller. And then on that click callback, you just call navigate, and job's done. Profit. You might have noticed, actually, there were a few references to cheese here, and I feel like I need to justify this. So I'm not obsessed with cheese. I don't even like cheese. But if you were there in Berlin, you might have noticed on the first day there was a random slide session, and my topic was cheese. So I had to give a presentation about cheese, and it was quite difficult. So, you know, just letting you all know, I don't even like cheese. So, what if you have an activity result? In some cases, you might have an activity going from activity to actually retrieve a result from this. Now, unfortunately, this isn't quite handled yet. The recommendation is to use a shared view model between these two screens. So you can have a fragment with a view model and a fragment with the same view model, and you can communicate across these, sort of like an event bus or a bus of events. This is the recommended approach, but however, there is an issue on the Google issue tracker, which I recommend go checking out and voting for if you would like to see this feature implemented. It would be able to kind of start a fragment for results. And it's quite an interesting kind of behavior. There's also method of communication with these two. So if you are using the shared view model, you probably want to make sure that you're using an event base. So this is like something that can only be consumed once. There's a great article from Jose about using event. This is similar to the single live data approach, but it means you don't have to have a custom class extending live data if you like live data. Dynamic features, you might be asking. That's a bit tricky. So if you're using dynamic features, that means that the module needs to be sort of above your application, which means that if your fragment argument definition is defined in this module that sits above app, then it can't actually know about those. So how do you navigate upwards if you don't have a dependency, which you can't have a dependency for? It's coming soon. I've spoken to a few of the Google developers, and I've been promised that it will be arriving sometime between now and the end of time. So fingers crossed for that one. Let's hope it comes soon. If you like these topics, I really recommend you watch the video from Ian Lake, the single activity, why, when, and how. This is a really good explanation, and it goes into a lot of concepts about testing, about how to do testing with these individual fragments, and it's really, really useful, and a lot of the concepts I used in this talk. Yeah, so thank you. I feel I have to take this opportunity for a bit of shameless self-promotion. I'm also doing 2 talks tomorrow on RxJava and coroutines and implementing a paging library. Please go down.
Does anyone have a question?
All right.
So let's navigate to the break. Thank you so much. Hands of applause to the panel.